Hello everyone, good evening. So here we shall give the solutions of the test on quadratic equations and triangles, which was held on August, and the full marks was out of 50. So here the first question, it has been told that the value of k for which the quadratic equation ax square minus 5x plus 1 equals to 0 does not have a real solution. Does not have a real solution is. Does not have a real solution is. So the first option is the 0. Option B is 25 by 4. Option C is 4 by 25. Option D is 7. So here we need to find the value of k for which this quadratic equation is not having any real solution. So the formula is that if the quadratic equation, the quadratic equation ax square plus bx plus c equal to 0 will have no or will not have a real solution if b square minus 4ac is less than 0, or I can say that b square is less than 4ac. B square is less than 4ac. So it means here the quadratic equation kx square minus 5x plus 1 equal to 0. This will have no real solution. So it means that b, here b is minus 5 and a is k and c is 1. So therefore b square which is 25, that should be less than 4ac, means 4 into k into 1. So it means 4k, that should be greater than 25. So it means k should be greater than 25 by 4. K should be greater than 25 by 4. It means k should be more than 4, 6, 24, so 6.25. So k should be, so any value of k we can take which is more than 6.25. So we can take 7. So option D is the correct answer. Then question number 2 has been told that the roots of the quadratic equation is 3x square minus 4 root 3x plus 4 equal to 0 are A, that is not real, and B, that is real and equal, and C is rational and distinct. Option D is irrational and distinct. So we have to find the nature of the roots. So we have to find the value of the discriminant. The discriminant is given as b square minus 4ac. So if b square minus 4ac is less than 0, then the roots are not real. And if b square equal to 4ac, then if d, the rule is that if d is equal to 0, then the roots are real and equal. And if d is greater than 0, then the roots are real and distinct. And if d is less than 0, then the roots are not real. So we have to check the value of d here. And if d is not a perfect square, if d is not a perfect square, d is not a perfect square, then we can say that the roots are irrational and distinct. The roots are irrational. Roots d is not a perfect square and d is greater than 0 also. Then in that case, we can say that roots are irrational and distinct. So then, so here the quadratic equation is given as 3x square minus 4 root 3x plus 4 equal to 0. So here we can see that the value of a is the coefficient of x square. Since we have to compare it with the general expression of a quadratic equation, which is ax square plus bx plus c equal to 0. This is the general form of a quadratic equation. You can say it is a general quadratic equation form. You can say a general form of a quadratic equation. So then here if we compare it with this, then we get the coefficient of x square, which is a, that is 3, and b is minus 4 root 3, and c is 4. So here the value of the discriminant d, that is d is called the discriminant. So d is b square minus 4ac. So b minus 4 root 3 whole square minus 4 into a into c, 3 into 4. So this is equal to 4 for the 16, 16 into 3 minus 16 into 3, that is 48. So 48 minus 48, that is equal to 0. So here d is equal to 0. Hence we can say that the roots are real and equal. Hence we can say that the roots are real and equal. So hence option B is the correct answer. Then in question number 3, it has been told the values of k, for which the quadratic equation k plus 1 x square plus 2 into k minus 1 x plus k minus 2, that is equal to 0, has real roots. Is option A is k equal to 2, option B is k equal to 3, option C is k equal to 0, option D is none of these. Values of k for which the quadratic equation has real roots is so if it has real roots, so we know that for the quadratic equation, ax square plus bx plus c equal to 0, we have real roots. We have real root. We should have the discriminant, that is b square minus 4ac, that should be greater than or equal to 0. So here the equation is here the if we compare the general form of a quadratic equation with this given quadratic equation, then we get the coefficient of x square, which is a, that is k plus 1, and b is 2 into k minus 1, and c is k minus 2. So therefore, we can say that b square, which is 4 into k minus 1 whole square, b square minus 4 into a, k plus 1 into c, which is k minus 2. That should be greater than or equal to 0. So therefore, from here 4 I can take as common and I can cancel out. And then here we will get k minus 1 whole square, means k square minus 2k plus 1, minus this will be k plus 1 into k minus 2, means k square minus 2k plus k. So this is minus k minus 2, that is greater than or equal to 0. So it means k square minus 2k plus 1 minus k square plus k plus 2, that is greater than or equal to 0. So k square will get cancelled. Then here you can see minus 2k plus k, that is minus k plus 3, that is greater than or equal to 0. So it means k should be less than or equal to 3. You can say k, if I take this on the right hand side, so k should be less than or equal to 3, then only it will have real roots. b square minus 4ac is k minus 1 whole square ac minus 2k plus k, so minus k minus 2, k square will get cancelled, minus 2k plus k, so that is minus k plus 3, that is greater than or equal to 0. So from here only I can show that minus k should be greater than or equal to minus 3, so it means k should be less than or equal to 3. Okay, so should have, sorry, the question here, it should be, it has equal roots, it should have equal roots. Okay, so then it has been asked, so if it has got equal roots, to have equal roots, then the value of the discriminant should be equal to 0. So we have to equate it to 0 only. Instead of the inequality sign, we have to just equate it to 0. So this should be equal to 0. So minus k plus 3 is equal to 0, implies k should be equal to 3. So option B is the correct answer. Then in question number 4, it has been told that if the equation x square plus 4k x square plus 4x plus k equal to 0 has real and distinct roots, then option A, k should be equal to 4, k is less than 4, c is k is greater than 4, and d is k not equal to 4. So we know that to have real and distinct roots, the value of the discriminant, that's which is b square minus 4ac, that should be greater than 0. You have real and distinct roots. So here we can say, here it is given x square plus 4x plus k equal to 0. So if we compare it with ax square plus bx plus c equal to 0, then we can say that here a is equal to 1, since it is the coefficient of x square, and b is equal to 4, which is the coefficient of x, and c is the constant term, which is k here. So we can say that b square, which is 16 minus 4 AC, so 4 into 1 into k, that is greater than 0. So it means that 16 minus 4k is greater than 0. So it means that 16 is greater than 4k. So it means that 4k is less than 16. So k is less than 4. K is less than 4. So option B is the correct answer. So then question number 5, in question number 5 it is told if triangle ABC is similar to triangle PQR, does that 3 times AB, that is equal to 2 times PQ, and BC is equal to 10 centimeter, then length QR is equal to, the length QR is equal to how much? That we have to find out. So if triangle ABC is similar to triangle PQR, then we can say that, okay, so here the options are 10 centimeter, option B is 15 centimeter, option C is 20 by 3 centimeter, and option D is 30 centimeter. So we have to choose the correct option. So here we can say that if triangle ABC is similar to triangle PQR, then we can say that AB by PQ, that is equal to BC by QR, that is equal to AC by PR. Since why? Since the corresponding sides of congruent, no, since the corresponding sides of similar triangles are proportional. Since the corresponding sides, since the corresponding sides of similar triangles, corresponding sides of similar triangles are proportional. Proportional. So here, so therefore, now it is told that now here, so here it is given 3AB, that is equal to 2PQ. It is given. So I can say that since AB by PQ, that is equal to 2 by 3, which is also equal to BC by QR. So now BC is given as 10 centimeters. So 10 centimeter divided by QR, that is equal to 2 by 3. So therefore QR, that will be equal to 3 by 2 times 10 centimeter, which is 2 5 10, so 15 centimeter. Option B is the correct answer. Then in question number 6, it has been told that O is the point of intersection. O is the point of intersection of two chords. O is the point of intersection of two chords AB and CD. AB and CD of a circle. If angle BOC, equals to 80 degree and OA equals to OD, then triangle ODA and triangle OBC. Triangle ODA and triangle OBC are, the options are, option A is equilateral and similar. Equilateral and similar. Option B is isosceles and similar. Isosceles and similar. Option C is isosceles but not similar. Isosceles but not similar. And D is not similar. So here one circle has been given. So in the circle, two chords are given. Is A, D, O, B, and C. So here it is given that OA equals to OD and angle BOC, this is 80 degree. This is given. So now, as you can see that we know that here we can use one theorem that uh, angles subtended by the same arc on the same side of a circle are equal. Angles subtended by the same arc angles subtended by the same arc of a circle on the same side of it the same side of it on the remaining part of the circle are equal. The remaining part of the circle are equal. So hence it means I can say that these two angles are equal. So hence I can say that angle ADO that will be equal to angle CBO. Since why they are subtended by the same arc AC on the same side of the circle on the remaining part of the circle. Similarly, I can say that these two angles are equal, which means an angle DAO that will be also equal to angle DCO. Since why they both are subtended by the same arc BD on the remaining part of the circle. So, and also we can say that in triangle OAD, OD is equal to OA, which is given. So hence, so we can say that angle OAD that will be also equal to angle ODA. OAD will be equal to angle ODA. So these two angles are also same. So this is 80 and this is also 80 since they are vertically opposite angles. So now these two are equal. So hence each of them will be 180 minus 80 divided by 2, which is 100 by 2, that is 50 degree. So each of these two angles is 50 degrees. So these two angles, so as we know that this angle D is equal to angle C. No, angle D is equal to angle B. So hence I can say this is also 50 degree and this is 50. Angle A is also equal to angle C, which we have shown. So this is also 50 degree. So it means both triangles are isosceles triangles only. So since this is 50, angle B and angle C are 50 or 50 each. So I can say OB is equal to OC also. So hence both are isosceles triangles and both of them have all the three angles same. So I can say these two triangles are similar also. So hence we can say that hence triangle ODA that is similar to triangle ODC by angle by a rule of similarity. A rule of similarity since all the three angles are same and they are isosceles also since two sides are equal. So hence they both are isosceles and similar. So option B is the correct answer. And in question number 7, it is told if triangle ABC is similar to triangle PQR and angle A equals to 32 degree and angle R that is equal to 65 degree, angle R is equal to 65 degree, then the measure of angle B is. Then the measure of angle B is. And here also the options are 32 degree, B is 65 degree, C is 83 degree, and D is 97 degree. 97 degree. So now these two triangles are similar. So here we can say that, let's say this is triangle ABC, this is triangle ABC, and this one is say PQR. So it is given that ABC is similar to triangle PQR. So hence we can say that angle A should be equal to angle P, and angle B should be equal to angle Q, and also angle C should be equal to angle R. Since why? Since corresponding angles in similar triangles are equal. Since corresponding angles in similar triangles are equal. Similar triangles are always equal. So now, hence we can say that angle B, we have angle A is given, that is 32 degrees. So angle P should be also 32 degrees. Angle R is given as 65 degrees. So it means angle C also should be 65 degrees. So now, therefore, angle B, therefore I can say angle B is equal to angle Q, that should be equal to 180 degree minus 32 plus 65. Means the sum of the angles, sum of the three angles is 180 degree. So this should be 180 degree minus 97 degree. So this should be 83 degree. Option C is the correct answer. Then in question number 8, it has been told that if in two triangles, ABC and PQR, AB by QR, that is equal to BC by PR, is equal to CA by PQ. CA by PQ. Then option A is that triangle PQR is similar to triangle CAB. Option B is triangle PQR, that is similar to triangle ABC. And option C is triangle CBA, that is similar to triangle PQR. Option D is triangle BCA. Triangle BCA is similar to triangle PQR. So here AB by QR. So here we can see that AB by QR. So ABC, and this is suppose QR. So here as it is told, so AB by QR, that is equal to BC by PR, that is equal to CA by so that is given as yeah, it's equal to CA by PQ. So hence from here we can see that this by this AB by QR, that is equal to BC by PR, that is equal to CA by PQ. So hence from here only we can see that the point A corresponds to Q, B corresponds to R, and C corresponds to P. So hence we can say triangle PQR will be similar to, since we have to follow the order, we have to follow the order when we are writing the similarity of two triangles. So PQR will be similar to triangle CAB. CAB, or we can also say triangle ABC, or triangle ABC will be similar to triangle QRP. Or if we tell CBA, triangle CBA, that will be similar to triangle PRQ. And triangle BCA, if we tell BCA, that will be similar to triangle RPQ. So hence option A is the correct answer, since ABC will be similar to QRP, not PQR, and CBA will be similar to PRQ, not PQR, and BCA also will be similar to RQ. So all the BCD options are wrong, but option A is the correct answer. Then in question number 9, it has been told that, so it is assertion and reason based. And so in the assertion, it is told that if one root of the quadratic equation, 2x squared plus kx minus 6 equal to 0 is 2, then k is minus 1. K is minus 1. And the reason is, if the discriminant p equals to b square minus 4ac is less than 0, then the roots of the quadratic equation, ax square plus bx plus c equal to 0 are imaginary. Not imaginary. So if the root of this is 2, then k is equal to minus 1. So hence we know that any root of any quadratic equation will satisfy the equation also. So any root of a quadratic equation, so this is the rule which we have to use, that any root of a quadratic equation will also satisfy the equation, will also satisfy the given equation. So hence we can say that here it is given 2x square plus kx minus 6 equal to 0, and one of the root is 2. So it means that x equal to 2 will satisfy the quadratic equation, which is 2x square plus kx minus 6 equal to 0. So hence we can put x as 2. So therefore we can say 2 into 2 square plus k into 3 minus 6, that is equal to 0. So it means 4 to the 8, 8 plus 2k minus 6, that is equal to 0. So therefore 2k plus 2, that is equal to 0. So 2k equal to minus 2. So k is equal to minus 1. K is equal to minus 1. So hence k will be minus 1 if x equal to, if 2 is the root of this given equation. So hence the assertion is true. And then the reason is told that if the discriminant is less than 0, then the roots of the quadratic equation are imaginary. So obviously that is also true. Hence if the discriminant is negative, then the roots of the quadratic equation are imaginary. It means that the roots are not real. The roots are not real in that case. So hence both the assertion and reason is true, but the reason is not the correct explanation of the assertion. So hence option B is the correct answer. Since both A and R are true, but R is not the correct explanation of A. And in question number 10 has been told that the assertion is given that ABCD is a trapezium. PCT is a trapezium with DC parallel to AB, DC parallel to AB, and E and F are points. E and F are points on AD and BC, on AD and BC respectively, on AD and BC respectively, so that EF is parallel to AB. EF is parallel to AB. Then AE by ED, that is equal to DF by F. DF by F. And then the reason is given as any line parallel to the parallel sides, any line parallel to the parallel sides of a trapezium divides the non-parallel sides proportionally. Divides the non-parallel sides proportionally. So here it is given that ABCD is a trapezium where AB is parallel to DC and E and F are points on AD and BC. E and F are points on AD and BC, so that EF is parallel to AD. Then we have to show that AE by ED, that is equal to BF by FC. So here what we can do, we can join AC. And join AC, and we can say that suppose AC intersects EF at the point G. So here we can see that EG is parallel to DC in triangle ACD. So we can say that AE by ED, that is equal to AG by, no, sorry. We can say that AE by ED, that is equal to AG by GC. Hence, by using the basic proportionality theorem, and also similarly in triangle CAB, GF is parallel to AB. So we can say that CG by GA, that is equal to CF by FB. So hence we can say that, so from here we can see that AE by ED, that is equal to AG by GC, and from here I can say AG by GC, that is equal to BF by FC. So hence that is equal to BF by FC. So hence we can say that AE by ED is equal to BF by FC. So hence true. So hence we can say that the assertion is true. And the reason is a line parallel to parallel sides of a trapezium divides the non-parallel sides proportionally. So this fact only we have proved it here by using the basic proportionality theorem. Hence why the basic proportionality theorem says that if in a triangle a line is drawn parallel to the third side, then the other two, if a line is drawn parallel to one side, then that line will divide the other two sides proportionally. Suppose this is ABC, I can say that this is DE, then I can say AD by DB, that is equal to A by EC. This is called as the basic proportionality theorem. So that only we have used it to prove the fact that any line which is parallel to a trapezium, that also will divide the non-parallel sides proportionally. So hence the assertion is true and the reason is also true, and the reason is the correct explanation of the assertion also. So option A is the correct answer. Option A is the correct answer. Then in the section B, in question number 11, it is told that find the value of P for which the quadratic equation find the value of P for which the quadratic equation px into x minus 3 plus 9 equal to 0 has equal roots. Has equal roots. So therefore, the given quadratic equation, you can say that this is px square minus 3px plus 9, that is equal to 0. Px square minus 3px plus 9 equal to 0. So this will have equal roots. So we know that for having equal roots, the discriminant should be equal to 0, which means b square minus 4ac, that should be equal to 0. In the quadratic equation, which is ax square plus bx plus c equal to 0, here b square minus 4ac should be equal to 0, then only we can have equal roots. So here you can see that b, the value of b is minus 3p, and a is p, and c is 9. If we compare the given equation with the general form of the quadratic equation, so here it means minus 3p whole square minus 4ac means minus 4p into 9, that should be equal to 0. It means that 9p square minus 36p, that should be equal to 0. So I can say we can take 9p as common from these two. So 9p into p minus 4, that should be equal to 0, which means p into p minus 4, that should be equal to 0. It means p can be equal to 0 or 4, but p here can't be 0, since if p is 0, then it will not be a quadratic equation. Since if p equal to 0, then it is not a quadratic equation. Or we can say that if p is 0, then it will be 9 equal to 0, which is having no solution at all. So hence p can't be 0. So hence p should be equal to 4. So hence p should be equal to 4. So p equal to 4 is the only answer. P is equal to 4 is the correct answer. Then In question number 12, question number 12 is told to solve for x, which is 9x squared minus 6px plus p square minus q square, that is equal to 0. So if we solve it, then we will get so here we can say that this is 9x square minus 6px plus p square and minus q square, that is equal to 0. So hence we can say that this will be obviously 3x whole square. So 3x whole square minus 2 into 3 into 3x into p. So this is 3x square minus 2 into 3x into p plus p square and minus q square, that is equal to 0. So here we can see that this is of the form a square minus 2ab plus b square. So it is a minus b whole square. So it is 3x minus p whole square minus q square, that is equal to 0. So hence we can say that this will be 3x minus p. So a square minus b square, we know that a square minus b square is a plus b into a minus b. So we can factorize it. So this will be 3x minus p plus q into 3x minus p minus q, that is equal to 0. So hence we can say that 3x will be equal to, so either we can say that 3x minus p plus q equal to 0 or 3x minus p minus q equal to 0. So we can say that 3x will be either p minus q, or we can say 3x will be equal to p plus q. So hence we can say that the required values of x are, one is p minus q by 3 and p plus q by 3. So these are the two solutions of x. So this is the answer. Then in question number 13, it has been told that find the values of k for which the quadratic equations and the values of k for which the quadratic equations k plus 4 into x square plus k plus 1 into x plus 1 equal to 0 has equal roots. The value of k for which this quadratic equation has equal roots. So we know that if ax square plus bx plus c equal to 0 has equal roots, then the discriminant d, that is equal to b square minus 4ac, that should be equal to 0. So here we can see that where if we compare this given equation with the general form of the quadratic equation, then we get that a will be equal to k plus 4, b is equal to k plus 1, and c is equal to 1. So therefore the discriminant, that is equal to b square, so k plus 1 whole square minus 4ac, so 4 into k plus 4 into 1, that is equal to 0. So hence we can say that k square plus 2k plus 1 minus 4k minus 16, that is equal to 0. So hence we can say that this is k square minus 2k, then minus 15, that is equal to 0. So if we factorize it, then we know that 5 3 is 15. So k square minus 5k plus 3k minus 15, that is equal to 0. So I can take k as common from the first two terms. So k into k minus 5 plus 3 into k minus 5, that is equal to 0. So I can say k plus 3 into k minus 5, that is equal to 0. So hence you can say that either k plus 3 equal to 0 or k plus 3 equal to 0 or k minus 5 equal to 0. So hence the values of k are k will be minus 3 and or 5. So minus 3 and 5, these are the two required values of k for which the given equation will have real and equal roots, for which the given quadratic equation will have real and equal roots. So k equal to minus 3 and 5 is the answer. Then in question number 14, it has been told that the difference of two numbers, the difference of two numbers, the difference of two numbers is 5, and the difference of their reciprocals, is 1 by 10. Find the numbers. The difference of two numbers is 5, and the difference of their reciprocals is 1 by 10. Then find the numbers. So let's say we take let the numbers be x and y, where suppose x is greater than y. So if x is greater than y, therefore I can obviously say 1 by x will be less than 1 by y, and where each of them, they are not equal to 0. I'm saying x and y are not equal to 0, and x is greater than y. So it means their reciprocals, when we take, the inequality sign will change. So therefore 1 by x will be less than 1 by y. So I can say the difference of them, difference, it means x minus y, that should be equal to 5, since x is more than y. And the difference of the reciprocals, when we take, then we should not say 1 by x minus 1 by y. We should tell 1 by y minus 1 by x, that is equal to 1 by 10. Since x is more than y, so 1 by x should be less than 1 by y. So we have to find the numbers. So these are the two equations we have to solve. So now one equation, can say y is equal to, I can say y is equal to x minus 5. So this we can put in place of y here in the equation 2. So we can say that 1 by x minus 5 minus 1 by x, that is equal to 1 by 10. Now if you take the LCM of the denominators, this will be x into x minus 5, and here it will be x minus of x minus 5, that is equal to 1 by 10. So hence we can say that this will be x minus x plus 5 divided by x square minus 5x, that is equal to 1 by 10. So x and x will get cancelled. So I can say x square minus 5x, that is equal to 50. Or we can say that x square minus 5x minus 50 equal to 0. So hence we can say that this will be x square minus 10x plus 5x minus 50, that is equal to 0, since 5 tens are 50. So I can say this would be x minus 10 into x plus 5, that is equal to 0. Since y, we can take x as common from the first two terms, then we will get x minus 10, and plus 5 I can take as common from the next two terms. This will be x minus 10 equal to 0. So x minus 10 I can take as common, then it will be x minus 10 into x plus 5 equal to 0. It means that x can be minus 5 or 10. So therefore, one thing is x is minus 5, then y will be minus 5, which is minus 10. And if x is 10, then y will be 10 minus 5, that is equal to 5, since y is x minus 5. So therefore, it means that the numbers can be either minus 5 and minus 10 or 10 and 5. So therefore, the answer is that the two numbers can be either minus 5 and minus 10, or it can be minus 5 and minus 10, or it can be 10 and 5, or it can be 10 and 5 also. Since why in both the cases the given conditions will be satisfied. Even in question number 15, then in question number 15 it is told that in figure, the given figure, CB is parallel to QR. CB is parallel to QR, and CA is parallel to PR. Also, AQ equals to 12 centimeter, AR equals to 20 centimeter, and PB equals to CQ equals to 15 centimeter. PB equal to CQ equal to 15 centimeters. Then calculate PC and QR. Calculate PC and DR. So here it is given, this is PQR, and this is ABC. So it is given CB is parallel to QR, and CA is also parallel to PR. So given AQ is 12 centimeter, AR is equal to 20 centimeter, and CB, that is equal to CQ, that is 15 centimeter. We calculate PC and PR. So here we can say that by using the basic proportionality theorem, we can say that since here CB is parallel to QR. So I can say PC by CQ, that is equal to PB by PR. Hence I can say PC by CQ is 15 centimeter, that is equal to PB, that is 15 centimeter divided by VR. And similarly, I can see that AC is parallel to CA is parallel to PR. So we can say that by basic proportionality theorem that QA by AR, that is equal to QC by CD. So hence QA, that is 12 centimeter divided by 20 centimeter, that is equal to QC. QC, that is 15 centimeter divided by PC. So hence this two will get centimeter will get cancelled. So 4 3 are 12, 4 5 are 20. So I can say PC, that will be equal to 3 into PC, that is equal to 15 into 5 centimeter. So I can say PC will be equal to 15 into 5 divided by 3 centimeter. So that is 3 5 to 15. So that is 25 centimeters. So PC is 25 centimeter, and also we can say 25 by 15, that is equal to 15 by BR. So hence you can say BR, that is equal to 15 into 15 divided by 25. So which is 5 5 of 25, 5 3 15, 5 3 15. So BR is 9 centimeter. So therefore we can say the answer is PC is 25 centimeter and BR is 9 centimeter. So this is the required answer. Then in question number 16, it has been told, find the value of x, find the value of x in the given figure. Find the value of x in the given figure. So here the figure is given as, figure is like this, or one triangle is given, that is ABC, triangle ABC is DE. Here find the value of x in the given figure here such that it is given such that DE is parallel to AB. DE is given parallel to AB, and this is 3x plus 9, 19. DE is DC is x plus 3. This is x. This is 3x plus 4. So here we can say DE is parallel to AB. So obviously you can say that CD by DA. CD by DA, that is equal to CE by EB. CE by EB. So I can say CD, that is x plus 3 divided by DA, that is 3x plus 19, that is equal to CE, that is x divided by EB, that is 3x plus 4. It means that x plus 3 into 3x plus 4, that is equal to x into 3x plus 19. So x into this, so that will be 3x squared plus 4x plus this is 9x plus 12, that will be equal to 3x squared plus 19x. 3x squared will get cancelled. This will be 12, that is equal to 19x minus 13x. Since 4x plus 9x is 13x, that means 6x, that is equal to 12. So x is equal to 2. X will be equal to 2. So x equal to 2 is the answer. Then question number 17. Question number 17, it is told to solve for x. Solve for x. Is 4 by x minus 5 by 2x plus 3, that is equal to 3. So if we take the LCM of the denominators, then this will be x into 2x plus 3. And then in the numerator, that will be 4 into 2x plus 3 minus 5x, that is equal to 3. So then you can say that this will be 8x plus 4 3 that 12. minus 5x, that is equal to 3 into x into 2x plus 3. So this will be 8x minus 5x, so that is 3x. So 3x plus 12, that is equal to 3x into 2x plus 3. So from here 3 I can take as common. This will be 3 into x plus 4, that is equal to 3x into 2x plus 3. So 3 I can cancel out from both the sides. So then you can say this will be x plus 4 equal to 2x square plus 3x, 2x square plus 3x. So then this will be, you can say 0, that is equal to 2x square plus 3x minus x minus 4. So this will be 2x square plus 2x minus 4, that is equal to 0. Two x square plus 2x minus 4 equal to 0. So this will be x square plus x minus 2 equal to 0. So then we can factorize it since 2 1 are 2. So this will be x square plus 2x minus x minus 2 equal to 0. So this will be x I can take as common from the first two terms. This will be x into x plus 2 minus 1 into x plus 2, that is equal to 0. Then we can take x plus 2 as common. So this will be x plus 2 into x minus 1, that is equal to 0. So I can say that x will be equal to 1 or minus 2. 1 or minus 2. So these are the required two values of x. Here are the required two values of x. So this is the required answer. Okay. So then in question number 18 has been told to solve for x. Solve for x where it is given 1 by a plus b plus x equals to 1 by a plus 1 by b plus 1 by x. We have to find the values of x. So here we can take all the variables on the left hand side. So this will be 1 by a plus b plus x minus 1 by x, that is equal to 1 by a plus 1 by b. So then you can take the LCM of the denominators. So that will be x into a plus b plus x. And then in the numerator, that will be x minus of a plus b plus x. That is equal to, here also we can take the LCM, that is AB, and this will be b plus a. So then this will be x minus of a minus b minus x divided by x into a plus b plus x is equal to a plus b divided by ab. Now here you can say x and x will get cancelled, and here we can see this will be minus of a plus b into ab, that is equal to a plus b into x into a plus b plus x. So a plus b I can cancel from both sides since provided that a plus b is not equal to 0. If a plus b is not equal to 0, then we can uh, cancel it from both sides. And here also a and b should not be 0 only. And a and b also should not be 0 here, since if they are 0, then these two terms will become undefined. So now we can say that this will be minus ab, that is equal to x into x plus a plus b. So then this will be minus ab equals to x square minus x square plus ax plus bx. So we can say that this will be x square plus a plus b into x plus ab, that is equal to 0. Since why we can take this on the right hand side, and then we can say 0 equal to x square plus ax plus bx plus ab. So then we can interchange both the sides of the equation. So then here we can see that this will be x square plus ax plus bx plus ab equal to 0. So then here from the first two terms you can take x as common, x plus a, plus from the next two terms we can take b as common. So this will be b into x plus a, that is equal to 0. So from here we can see x plus a we can take as common from these two terms. So x plus a into x plus b, that is equal to 0. So this will be, so x plus a equal to 0, or I can say x plus b equal to 0. So it means that x will be equal to minus a and minus b. So minus a and minus b are the required values of x. So this is the required answer. Then question number 19. Question number 19, it has been told the sides AB, BC and the median AD and the median AD of triangle ABC are respectively proportional to the sides PQ, QR and the median PM and the median PM of another triangle PQR. Then prove that triangle ABC is similar to triangle PQR. Prove that triangle ABC is similar to triangle PQR. So here, first to draw the figure. So this is ABC and this is PQR. It is given AB by AB and BC are proportional to PQ and QR, and the median AD also, and PM, AD and PF, okay, are proportional. So here it is given that in triangle ABC, and triangle PQR, AG and PM are the medians, and also I can say AB by QR, that is equal to BC by Q. No, sorry. It is given that AB by PQ is equal to BC by QR, that is equal to AD by PM. This given, since it is given that AB, BC and AD are proportional to PQ, QR and PM. So then we have to prove that triangle ABC is similar to triangle PQR. So how to prove it? We have to prove it like this. Now here we can see that we can say that D is the midpoint. D is the midpoint of BC in triangle ABC. Since it is given that AD is the medium which is given. Similarly, we can say that M is the midpoint of QR in triangle PQR. Since it is given that PM is the median which is given. So hence obviously we can say that DD that is equal to CD, that is equal to half of BC, and also QM that is equal to RM, that is equal to half of QR. So hence we can say that BC by QR, that is also equal to half of BC by half of QR. So that would be also equal to BD by QR. BD by QR. So hence, so now in triangle, you can say in triangle ABD and triangle PQM, in triangle ABD and triangle PQM, we can say that AB by PQ, which is equal to AD by PM, is equal to AD by PM, which is given, and also AD by PM, that is also equal to EC by QR, EC by QR, which is also given, which is also given. And also we can say that, so AD by PM, that will be also equal to half of BC by half of QR, which is equal to BD by Q1, which is proved earlier or proved above. So hence we can say that AB by PQ, that is equal to AD by PM, that is also equal to BD by BD by Q1, BD by Q1 in these two triangles. In these two triangles. In these two triangles, AB by PQ, we have shown that is equal to AD by PM, that is equal to BD by Q1. So hence we can say that triangle ABD is similar to triangle PQM. How? By SSS rule, by side rule of similarity, since all the three sides are proportional in these two triangles. So by SSS rule of similarity, we have shown that these two triangles are similar. So therefore, now we can say that angle B, that is equal to angle Q, or I can say that angle ABD, that is equal to angle PQR. Since why? Since corresponding angles, of similar triangles are equal. Corresponding angles of similar triangles are equal. Or therefore we can say, or from here only we can say that angle ABD, or I can say angle ABC, that is equal to angle PQR. PQR, or here we can say angle PQM. So PQM. So PQM and PQR is same thing. So these two angles are same. We have proved it. So now we can say in triangle ABC and triangle PQR, AB by BC, that is equal to AB by BC. No, sorry. AB by PQ, that is equal to BC by QR, which is given. And the included angle, which is angle ABC, is equal to angle PQR, which is proved above. So hence this is, so we have shown that two sides and the included angle, the two sides are proportional, and the included angle in these two triangles are equal. So hence you can say triangle ABC is similar to triangle PQR by SAS rule of similarity. The SAS rule of similarity, or we can say by SAS similarity criteria. So hence proof. Then in question number 20, is told that Amita buys some books. Amita buys some books for rupees 1920. If she had bought, if she had bought four more books, she had bought four more books for the same amount, for the same amount, each book would cost her, each book would cost her rupees 24 less, rupees 24 less, and prove that, triangle ABC is similar to triangle PQR. Triangle ABC is similar to triangle PQR. Triangle ABC is similar to triangle PQR. Sorry. Each book would cost her rupees 24 less. And how many books did he buy? Did she buy? What was the initial price of the book? What was the initial price of the book? This is the correct question. I think some printing mistake was there. So Amita buys some books for rupees 1920. If she had bought four more books for the same amount, then each book would cost her rupees 24 less. How many books did she buy? And what was the initial price of one book? What was the initial price of one book? So here we can say that let the initial price of the book, let the initial price of each book be rupees X. The initial price of each book be rupees X. So therefore I can say, therefore the number of books she had bought, the number of books she had bought for rupees 1920 is 1920 divided by X. So then it is given, that if she had bought four more books, so I can say that 1920 by X plus 4 for the same amount, then the cost of each book would be rupees 24 less. It means I can say that the number of books that would be 1920 divided by X minus 4, X minus 24. So it means that if the cost is rupees 24 less for each book, then the number of books that she will buy, that will be 1920 by X minus 24. That will be four more than she would have bought four more books by using the same amount. It means that 1920 by X plus 4, that is equal to 1920 by X minus 24. Hence I can say that 1920 by X minus 24 minus 1920 divided by X, can say minus, that will be equal to minus 4. Since why I took this on the left hand side, so the sign will change, and this I took on the right hand side, so the sign will change. So we can tell that this will be 1920 by x minus 24 minus 1920 by x, that will be plus 4. If we take minus 1 as common from the two sides. So therefore, we can take the LCM of the denominators. If you take the LCM of the denominators, that will be x into x minus 4. That will be equal to, this will be equal to 4 by 1920. So then this here it will be x minus of x minus 4. So then this will be x minus x plus 4. That will be equal to x into x minus 4. It will be equal to 4 by 1920. So then this will be x and x will get cancelled. So 4 into 1920, that will be equal to 4 into x into minus 4. So 4 and 4 will get cancelled. So x square minus 4x, that will be equal to 0. So 1920, if we factorize it, then this will be 2 9s are 18, 2 6 are 12, and 2 4s are 8, 2 8s are 16, and 2 2s are 4, 2 4s are 8, and 2 1s are 4, 2 2s are 4, 0, and 2 6 are 12, and it will be 16, 2 this will be 8, 4 is 32, this will be 2 3s are 6, 2 15s are 30. Let's say 1920, that we can say this will be equal to factorize it, this will be equal to 2 power 2 6 are 12, 7 4 are 8, 2 power 1 2 3 4 5 6 7, 2 power 7 into 3 into 5. This is, so it means I can say this will be 8 8 is 64 into 2. If 8 8 is 64, 64. Okay, so here okay, 8 to the 16, 16. So this is 32. 32 into 2 into 60. You can say this will be Okay, 3 into 32, 3 into 32 into 20 is 96 into 20. Sorry, here this should be 24, not 4. This should be 24. Should be 24. 24. It's 24. So this is 4, and this is 24. So 4, 6 are 24. So this will be 6 into this into 6 I have to do. This, so this will be actually x square minus 24x, x square minus 24x minus, it will be 6 zeros are 0, 6 to z 12. It's going to 54, 55, 6, 1, 1, 5, 2, 0. That is equal to 0. So now this 1, 1, 5, 2, 0, 1, 1, 5, 2, 0, that we can say this will be equal to 2 power. Obviously, this is 1920 into 6. 6 to the 12, 6 and the 54, 55. Okay. So this will be actually 2 power 8 into 3 power 2 into 5. If we do the prime factorization of this, then we will get this one. Then this will be equal to, we can write this will be 3 into 32 into 32 is 2 power 5. And then we can do 3 into 5 into 2 power 3. That means this is actually 96 into this is 8, 12 is 40, 120. Since why 120 minus 96 if we do, then we will get 4, then 24 we will get. So hence it means that we have to divide this, you have to split this into minus 120 and 96. So this will be x square minus 120x plus 96x minus 1152, 0, that is equal to 0. So this will be, we can take x as common from the first two terms. So this will be x into x minus 120 plus 96 into x minus 120, that is equal to 0. So this will be x minus 120 into x plus 96, that is equal to 0. So then this will be x equal to minus 96 and 120. X equal to minus 96 and 120. Minus 96 and 120. So it means x can't be negative since the price of the book can't be negative. So therefore the actual price of the book, of each book, that is rupees 120, and the number of books that she had bought, the number of books by her, that is equal to that is 1920 divided by 120. 1920 divided by x, that is 120. So this will be 0 will cancel. So 12 ones are 12, 12 6 are 72. So that is 16. The 16 books she had bought, and the price of each book was rupees 120. So this is the